Today we will start with electricity. Starting with electricity, we will discuss about the charges. Charges is a mutual interaction between the two particles. Means when two particles are rubbed against each other, among one of them loses the electron while other accepts the electron. The one which loses the electron becomes positively charged while the other which gains the electrons become positively charged. Means excess of electrons, excess of electrons is negatively charged body, and deficiency of electrons positively charged body. Positive and negative charges were termed by Benjamin Franklin. Now we will discuss about the unit of charges. Unit of charge is coulomb. It is denoted by C. Now we will discuss about the elementary charge particles. Means the smallest charge known to us is the elementary charge. Its charge of electron. Means elementary charge is charge of electron. The charge on one electron is 1.6 into 10 to the power 9 coulomb. Means the elementary charge which is known to us is a charge of electron and its value is 1.6 into 10 to the power minus 19 coulomb. It implies that charge on any body can be calculated in the terms of the elementary charge. So we have a formula which calculates the charge on any body, that is Q is equal to N into A, where Q is charge on body, N is number of electrons which a body carries, E is charge on one electron. For example, if we want to calculate the number of charges which constitute 1 coulomb of charge, then we can calculate as this. Q is equal to 1 coulomb and E is equal to 1.6 into 10 to the power minus 19 coulomb. So we have to calculate the number of electrons. So Q equal to Ne. Q1, N we have to calculate, and E is 1.6 into 10 to the power minus 19. And solving this, we get 6.25 into 10 to the power 18 equal to N. Means 6.25 into 10 to the power 18 electrons are required to constitute a 1 coulomb of charge. Now we will discuss about the properties of the charge. First property of a charge is that the charge on any body remains conserved. Likewise, mass and energy. As mass and energy of any system remains conserved, similarly, charge on any body also remains conserved. Next property is quantization of charge. Means charge is quantized, which implies that charge on any body can be expressed as an integral multiple of the elementary charge known to us. that is Q on charge any body is equal to N into E, where N is whole number. N is whole number. N can never be fraction. It can never be any fraction. Next property is charge is associated with mass. Next property is charge is transferable. Means if we have any body which is charged kept near to uncharged body, then that charged body will induce charge on that uncharged body also. Means charge is transferred from a charged particle to an uncharged particle. On a conductor, charge always resides on its outer surface. Means if we have any metallic part or if we have any metallic sheet and it is charged, then the charge will reside on its outer surface only. Like charges always repel each other, while unlike charges always attract each other. This is the most important property of a charge. Its last property is that repulsion and attraction both occurs when the charges are kept together. But for the test, we consider that repulsion is the short test for the electrification of bodies. Means if we want to check that whether the body is positively charged or not charged or negatively charged, repulsion is considered as a short test. Now we will study about the most important law, that is Coulomb's law. According to this law, the force which is existing between the two charged bodies can be of attraction or repulsion that is directly proportional to the magnitude of charges, while it is inversely proportional to the square of the distance between them. That let us consider that two electric charges are kept having magnitude of Q1 and Q2, which are separated by a distance r. According to Coulomb's law, force of attraction or repulsion is directly proportional to the product of the magnitude of the charges. That is, F is proportional to Q1, Q2, and it is inversely proportional to the square of the distance separating them. Now we have two equations, equation 1 and equation 2. On combining these two equations, we have F is proportional to Q1 Q2 by R square and F is equal to K Q1 Q2 by R square, where R is constant of proportionality, where K is constant of proportionality. In SI unit, K has a value of, in SI unit, the value of K is 9 into 10 to the power 9, which is applicable only for air or vacuum. Now we will calculate the unit of K. To have its unit, K is equal to F into R square by Q1 Q2. Force is calculated in Newton, distance is calculated in meter, charges are calculated in coulomb. So unit of K comes out to be Newton meter square per coulomb square. This is the value of, this is the unit of K. Equation 3 represents the mathematical form of a Coulomb's law. Now we will discuss about electric current. Moving charges constitutes the electric current, means the rate of flow of charge is known as the electric current. It is denoted by I. I is equal to flow of charge with respect to time. So Q by T is equal to I. Q is equal to NE. So NE by T is also equal to I. Now SI unit of charge is ampere. The device which is used to measure the current is known as a meter. Direction of electric current. We know that there exist two charges, positive and negative charges. So, electric current was considered to flow from positive to negative charges. The direction of current in a battery or in a cell is taken from positive terminal of the cell or battery to the negative terminal of the cell or battery throughout the circuit. But for that, now we will study about the flow of electric current in a wire. An electric current is the flow of electrons in a metal wire when a cell or a battery is applied across its ends. In a metallic wire, there exist number of free electrons which are moving randomly. It shows the movement of electrons in a wire. But when the same wire is connected to cell or battery, then the electric force acts on the electrons present in this wire. Due to this negative end of the battery, these negatively charged electrons are repelled. So, these negatively charged electrons in a wire, when connected to a battery or a cell, moves from negative end to the positive, which implies that the direction of flow of electrons is just opposite to the flow of the conventional current. Now we will discuss about the types of current. There are two types of current. First is DC, that is direct current. This is a current whose value and direction does not vary with time. Its sources are primary cell or secondary cells. This direct current is mainly used in the phenomena like electroplating, electrolysis. Next is AC, alternating current. The current whose value and direction varies with time. The current which is supplied to our homes is alternating current. In India, the frequency of the alternating current supplied to our home is 50 Hz, while its frequency in America is 60 Hz. The sources which provides us AC are power stations, means the current where the electricity is produced. Now we will study about electric field. Electric field due to a charge is the space around the charge in which the electrostatic force of attraction or repulsion due to a charge can be experienced. Means if we have a charge Q naught present here, then there must be a space or a region around it where any other charge will experience a force of attraction or repulsion. This space around it is known as the electric field. This space is electric field. The charge which produces the electric field is known as the source charge. The source charge is taken very small and positive. It is taken positive just for the convenience. Electric field intensity at any point is the strength of the electric field at that point. It is defined as force experienced by a unit positive charge at that point. It is denoted by E. Electric field intensity is a vector quantity, means it depends upon the direction as well as on the magnitude. Its SI unit is Newton per Coulomb. Electric potential. Electric potential is a quantity which determines the flow of charge. Likewise, we know that the water always flows from higher level to lower level. Similarly, the charges also flows from higher potential to lower potential. But the electric potential at a point is defined as amount of work done in bringing a unit positive charge from infinite to that point against the electric field. For example, if we fix a point A and a charge has to be brought from infinite to point A. So, some amount of the work has to be done to bring a charge Q from infinite to point A. That work done per unit charge gives you the electric potential. Let us consider that W is a work done to bring a charge Q from infinite to a point A. Then electric potential will be work done per unit charge. Unit of potential. SI unit of potential is volt, where 1 volt is equal to 1 joule of work done to bring a 1 coulomb of charge from an infinite to a given point. For a current to flow, the necessary condition is that there must exist the potential difference, which is defined as between the 2 points is an electric field. It is defined as the amount of work done in moving a unit positive charge. Means if we consider a point A to point B and the charge is kept at Q point, we have to take this charge from from point A to point B. For that, we have to do some work. That work done per unit charge gives us the potential difference, where W is work done in moving A charge Q from point B to point A. The device which is used to measure the potential is potentiometer. The device which is used to measure the potential is voltmeter.